So here we've got an alarm, and the volume of the alarm is represented by V. And we know in this question that the volume we're looking for is 70. So we're going to replace the volume with 70 in the equation and solve for the time, because when is what we're looking for at the time. So the first step is to subtract 60 from both sides. So if I subtract 60, I end up with 10 equals 18 sine of 12t. Next step is I need to get rid of that 18, so I'm going to divide both sides by 18, and that leaves me with 10 over 18 equals the sine of 12t. So my next job is to get rid of the sine, and the opposite mathematical operation of sine is inverse sine. So I take the inverse sine of both sides, and that leaves me with inverse sine of 10 over 18 equals 12 times t. And if you take the inverse sine, making sure your calculator is in degrees, you will get 33.75 equals 12t. So the last step is to divide both sides by 12, and that leaves a time of 2.8 seconds. So it will hit a volume of 70 decibels at 2.8 seconds. Now the other question is not a mathematical one, but just trying to understand the problem. Why do you think they fluctuate the alarm? And there may be several reasons for this, but one is so that it draws attention to itself, just like a siren on a police car or an ambulance. It fluctuates as well. It's not a steady hum, and that's the same reason that a noisy factory would use it too. It's so that it draws attention to itself, and people actually would react to the siren.